This is my math ISU video. So the first unit is trigonometry. The first question is a trig identity question. And it is prove 1 minus cos squared theta over 1 minus sine squared theta equals tan theta times tan theta. So we're going to work on the right side first because it's easier in my opinion. So we're going to leave this side first and then work on this side. So if we look on our worksheet, tan theta equals sine theta over cos theta. We want to get everything to sine or cos because then it makes it a lot easier. So tan theta is equal to sine theta over cos theta, and then tan theta again, which is sine theta over cos theta. Now what we want to do is we can multiply these. So we can multiply across. So then sine theta times sine theta gives us sine squared theta over cos theta times cos theta gives us cos squared theta. Okay, and then this is 1 minus cos squared theta over 1 minus sine squared theta. Okay, we got everything on this side. Now we have to simplify this side. So I'm going to move over here. So 1 minus cos squared theta is equal to sine squared theta, and 1 minus sine squared theta is equal to cos squared theta. So we can convert that. So 1 minus cos squared theta is equal to sine squared theta over 1 minus sine squared theta is equal to cos squared theta. And then the right side, put that in the equation, equals sine squared theta over cos squared theta. There you go. We have to get both sides the same. Sine squared theta equals sine squared theta over cos squared theta equals cos squared theta. Everything's the same. This question is done. Okay, the second question. This is a word problem question. Tom is standing 15 meters away from a building. When looking at the top of the building, he makes an angle of 60 degrees. Determine the exact height of the building. So first, what we want to do is make a diagram. So this will be my building here. Tom is standing 15 meters away, and he makes that angle right there. Okay, so we know that this angle that he makes at the top of the building is 60 degrees. We know he's standing 15 meters away, so this side is 15 meters. Okay, so we want to find the height of the building here. We want to find the exact height of the building. So if we look back on our special triangles, we can use that to get the exact height of the building. So 60 degrees, if we're looking from this angle, this side will be root 3. This side will be 1, and the hypotenuse will be 2. So there's our special triangle right there. Now what we want to do, so we want to get this side, so we use opposite over adjacent, because we have this side. That'll give us tan 60 is equal to x over 15, because opposite over adjacent. Now we just want to get x by itself, so we're going to move 15 to this side. 15, 10, 60 equals x. we want to get the exact value of tan 60 here. So 15 tan 60 opposite over adjacent is equal to root 3 over 1. This is basically times, because 15 tan 60. 15 is, we know, is always over 1. It's x, okay? Now we just multiply it, so then we're left with 15 root 3 over 1 is equal to x. That is the exact height of the building there. Alright, this is the second unit, exponential functions. First question, simplify the following. 2a to the 4 b squared over 6a to the 5 in b. That's all to the power of 2. So we know from our exponent laws that the coefficient to a power is just times itself by how many times the power is. So in this case it's 2. So we do 2 times 2, which is 4. And then we're also going to do 6 as well. So 6 times 6 is 36. And then we know the exponent to an outside power is multiplying from our exponent laws. We know that. So we're going to multiply 4 and 2. That's going to be a to the 8. And then we know 2 times 2 is 4. And then we'll do the same for the bottom here. 5 times 2 is 10. B, which is really just 1, times 2. That gives us B2. Okay, now we want to reduce this because we can reduce this fraction. So 4 goes into 36 9 times. Then we're left with 1 over 9. And then what we want to do is, we know that dividing, if we divide, that means the exponents subtract. So a minus this a, so 8 minus 10, that's negative 2 exponent. B minus b, so 4 minus 2, that's b squared. And so we cannot have a negative exponent. So what we want to do is bring this negative exponent to the bottom. So then you're left with b squared on the top, because that stays because it's a positive exponent. Bring this a to the negative 2 to the bottom. The 9 is there. And then we're left with 9a. And then this turns into a positive. That's your final answer right there. Though you can put the 1, but it doesn't matter. There's a 1. Technically, there's a 1 there. That's the answer. Okay, our last question. It's another word problem. It's an exponential growth or exponential decay question. In 2012, there were 100,000 Toronto Maple Leaf fans in Toronto. After each year, the fan base decreases by 4%. Create an equation to represent the population of the fan base. So the equation we're going off of is y equals a b to the x, where a represents initial amount, b equals the rate of increase / decrease, and the x equals number of times A increases or decreases. So we know, let's just start off with f at x. This is actually f at x equals AB, but it doesn't really matter, okay. Equals A, which is the initial amount. The initial amount is 100,000 because there are 100,000 fans. So 100,000 brackets, rate of increase is 4%, but we're decreasing by 4%. Decreasing, so if we decrease, it's 1 minus. If we're given a percent, it's 1 plus the percent as a decimal, or 1 minus the percent as a decimal. So we're decreasing, so it's 1 minus the percent as a decimal, 0.04, raised to the x there, because, okay. This is the equation. There's nothing else to do. A is done. B, what is the current population of the fan base this year, 2025? Okay, so we're going to use this equation, so I'm just going to write this down. 100,000, 1 minus 0.04. What we want to do is find the x. We have to find the number of times A decreases. So what we want to do for that is we need to find the difference between 2025 and 2012, like how many years is in between, because that's the number of increase, or the number of increase, decrease, or yeah. So then so 2025 minus 2012, you can do it this way. We'll give you 13, or you can just calculate how many, like, you can probably calculate by yourself what that is. Okay, so 2025 minus 2012, that's a 13-year difference. So, because we're finding the current population in 2025. Okay. Now we just plug this into our calculator. So we got 100,000 bracket 1 minus 0.04 to the exponent of 13. That equals 58,820 people, approximately. Okay, so this is the answer. This is the current population in the year 2025. So now for C, how many people left the fan base between these 2 years right here? All you have to do is take the initial amount in 2012 and minus it by the amount in 2025. That'll give you how many people left. So 100,000, that's the initial amount of fans, minus 58,820. That's how many fans are in 2025. That'll equal that'll equal 41,180. There's your answer right there.